Right. So we have just done a simple experiment where we have burned magnesium in air where it's reacted with the oxygen in the air. We know this reaction really well. We've done it probably a million times. We know that it gives off white light. The white powder that it makes is called magnesium oxide, an ionic compound. So we've gone from having elements to having ions. Ions are formed when electrons are gained or lost to make something more electrically stable. And this is exactly what redox is, the gaining or losing of electrons to make a usually more stable product. Oxygen has been added to the magnesium. So you could infer that magnesium was oxidized because oxygen was added. And that's exactly correct. If oxygen is added to something, we say it has been oxidized. Magnesium in this case was oxidized. We can also assign a number called an oxidation number to everything in there. And if that changes, we know that redox, oxidation reduction, has occurred. I'm going to teach you how to assign oxidation numbers in the next bit of learning. So just trust me that I've got these numbers correct for now. The oxidation number of any element is 0. So the oxidation number of magnesium and the oxygen on the left-hand side is 0. When it forms an ion, magnesium has a new oxidation number or state called positive 2. And the oxygen in this compound has gone to be oxide, and oxides have an oxidation number of negative 2. We notice that magnesium has gone up in oxidation number, and this is another way that we know that oxidation has occurred. The oxidation number goes up. And the last way that we know is what's happening to the magnesium at a particle level. It's going from being in a metallic bond with its 12 electrons being used to create that element to being magnesium ions where it's only got 10 electrons that it sort of owns, as it were, that belong to it. The other 2 have been transferred or lost to create the ionic bond. So the other thing that we notice is that in oxidation, anything that has an increased oxidation number, it doesn't always have oxygen added. It often just is losing electrons. And so what you'll often hear is a little phrase where it says, Leo, losing electrons is oxidation, goes Ger, gaining electrons is reduction. So these are opposites. If this happens to one thing, reduction has to happen to the other thing in the equation or in the reaction. So if oxygen is added in reduction, it means oxygen is lost. Well, yes, in the O2, as a molecule, it lost one of its oxygens to magnesium. So it did lose an oxygen. Sorry. Its oxidation number went from 0 to negative 2, so it reduced the opposite to this. Hence the word reduction, by the way. Reduction of oxygen, reduction of oxidation number. And the oxygen has gone from having, doing this maths very quickly, 8 electrons that are associated with it to having 10 because it has a stronger pull on that ionic bond, hence being ionic. So it has gained those electrons. Now, the only ones that we can use to know that it's definitely redox are the second and the third ones. These do not always happen. We've now found that a lot of oxidation reduction reactions occur without oxygen at all. But because the terminology and everything was created when it only involved oxygen, we've kept it being called oxidation and reduction rather than coming up with new words for everything. So these ones are always true. As I say, there's a nice little phrase that you can use or remember. Leo goes Ger. losing electrons oxidation, gaining electrons reduction. How that looks, and I see I'm running out of whiteboard space, but how that looks as an equation is we can break it up into two halves. We've got the magnesium being turned into magnesium ions, but this isn't balanced because this has got no charge, this side's got a positive 2 charge. So I add the 2 electrons as products because they are being lost to go to the oxygen one. To make our oxide ions there. So we need 2 of all of this to make that work. That is an overview of oxidation reduction. So the next thing we'll look at is how do I assign these oxidation numbers, because they are the fastest way to know if it's redox or not, before you go to the effort of writing equations and seeing if electrons have been transferred or not.